Welcome back, everybody. It is exciting to be back with you all again for this month's update. It's another AMA session, an Ask Me Anything session. It's always a really exciting time for me to be able to jump on one of these calls with all of you guys, thousands of people from all around the world that are connecting, all sharing the same passion, the same excitement, and wanting to see the latest updates of what's going on with the Hill project. Jason or Ruben, why don't you give us a little bit of an overview of what everybody can expect today?
Yes, Misha, super exciting. Actually, today we have a new format, which we have been working for some time. We want to improve the experience. And instead of just having the regular update that Jason describes what has been happening, we want to bring the visuals and the action into these AMAs. So we have been doing, uh, since the last AMA, a good report, the video of all the action, everything that has been happening in detail, and that has been reported in a very good video update. So then, we will be sharing that first. That will be the JSON update as usual, but with a lot of visuals. And after that, we're going to have the same usual AMA, Ask Me Anything. So prepare your questions, and after Jason's update, we will have the normal Q&A session live with Jason, and he's here with us. But the first format of update is going to be on the video because we want to bring you into the action with your eyes. So with no further delay, let's start rolling what has been happening lately at Hill Helicopters.
Good evening, ladies and gentlemen. Welcome to DC1 and thanks for tuning in for April's monthly update on the HX50 development program. We're trialing a new format tonight to try and keep it as punchy and focused as we possibly can. Do let us know what you think and we'll take that into consideration in time for next month. Let's start with some good news. After a successful Heli Expo show, our two aircraft have finally cleared customs and are on their way back to us. We continue to enjoy very strong sales, so our current sales figures are 919 X models and 370 Cs, a total of 1,289 aircraft in total. We've had a big push on a number of commercial areas in the business over the course of the last month, particularly recruitment. We're massively expanding our development team now to support the final push towards production and the certification and approvals program across the range of countries that we've got to execute that in a very short period of time. So if you're interested in working for us, do have a look at the website and come and talk to us. The main focus of this evening's update is going to be on the development of the GT50 engine and the development of our PC1 production facility. Let's get stuck in. Let's talk about the GT50 program. So over the course of the last 18 months or so, you've watched us develop all of the processes necessary to produce centrifugal impellers in-house. We started with aluminium, then we developed onto the specialist processes needed for cutting titanium, and now we're in the process of manufacturing the test impeller for the first GT50 engine. So what we've got here is we've now concluded the machining trials, just looking at optimizing the tool paths and the trade-off between machining time and tooling wear for the GT50 centrifugal impeller. So on this unit here, what you can see is in different vane passages, we've looked at different cutting strategies, all the way from the fairly benign through to very, very aggressive strategies, trying to get the cutting time and the tool wear down to the absolute minimum. We've got that to where we want it to be for now, parked that, and we've now produced the first 4 blanks for the first 4 test impellers. So these blanks have been cut from large forged billets, and now these, once they get into this state, have to be sent away for heat treatment prior to having their impeller vanes and blades cut into them. So those are off for heat treatment as the next step, and then we'll be cutting the first 4 impellers on the 5-axis right behind me. So this is the very first GT50 high pressure turbine disc going through the latest stages in its inspection process. So over the course of the last few weeks, we've machined that from a forged billet. You've seen us use the EDM machine, the wire eroder, to cut the fir trees using the process that we've developed there. And then we've also developed all now of the NDT processes to do the geometric inspection, and then also crack detection, X-rays, and the various other things that we need to get this to a production standard. So this is going through the last of its geometric inspections, having been through all the other processes, and then that will be ready to receive its blades. Let's talk GT50 turbine blades. So over the course of the last few months, you've watched us develop all of the processes necessary to cast high quality aerospace grade turbine blades in-house. What we've been focused on over the course of the last month in particular is the processes that are necessary to take raw superalloy material and then to make sure that our processes are tightly controlled to ensure that this cast stock is then processed into high quality turbine blades with predictable quality, low scrap rates, and the high mechanical properties that we need for service in the engine. In order to do that, we've had to develop an extensive range of controls for the casting process itself. We've had to develop a whole range of non-destructive testing processes, including composition analysis, mechanical testing, and various other controls that are required live on the process itself. And we've now completed that, and we're about to start the final set of qualification trials for our in-house turbine blade casting process. So you've seen us develop the wax trees and then the rapid prototype version of the trees to cast our power turbine and compressor turbine blades. What we're doing at the moment is casting some simple dumbbell samples, so we can take our cast material, cast that into dumbbell samples using the same processes as we use to manufacture turbine blades, and then machine these into the test samples we need to qualify the process and the mechanical integrity of these parts to the aerospace quality that we need. We have just today received the latest batch of crucibles that we need that are coated with a special compound to allow us to melt the alloys that we need safely. These are the crucibles that we're then going to go on and use to cast the dumbbell samples that we need, and then the first batch of GT50 HP turbine blades that will be put through the entire manufacturing process. So the casting process, the hipping, the heat treatment process, and also the root grinding process, and all of the NDT stages ready to go and be mated with the HP disc that I just showed you. It's not just turbine blades that we have to cast in superalloy materials, it's also the engine casing. So this is the combustion casing, so the hot section of the GT50 engine. This is just having some of its machine faces added here on the lathe. But one of the things that we've been doing a lot of work on over the course of the last week in particular is the in-house casting processes that we need to be able to produce these components inexpensively out of the superalloy materials that we need to. We previously showed you these rapid prototype patterns that we've had made that are used for the casting process to be able to produce these parts with the casting equipment that we're about to order. One of the things that we've been working on over the course of the last month is designing the runners and the feeds and the processing parameters to successfully cast large, thin-walled structures like this in really complicated materials. We've been doing a whole host of simulations to simulate how the molten metal runs through the mold, how it solidifies, how it cools, and controlling all of those parameters to make sure that we can repeatably make these, not just with full fill, not just with the right quality and low scrap rates, but also with the right crystal structure and the right mechanical properties to give us the performance that we need in service. That's gone really well, and I think within the next week or maybe 2 weeks, we'll be in a position to finally place the order for the production equipment that we need to produce these sorts of castings in-house at Production Centre 1. So there's a lot of work, quite rightly, gone into the difficult rotating components of GT50 over the last month or so. But don't let that let you think for 1 minute that we haven't been pushing forward with the drivetrain components as well. So pretty much everything that you need to make in a jet engine is difficult to manufacture. And one of the things that we've been working on over the course of the last month is some of the crucial drive shafts that go into the under-engine drive arrangement that GT50 uses to get drive from the speed reduction gearbox at the back of the engine forward and up into the main rotor, and then back down the centre of that shaft so that the main rotor is able to drive the tail rotor in the event of an auto-rotation. What you can see in front of me here is the primary drive shaft for the GT50 engine. So this spline on this external spline on the back of the engine picks up the drive from the speed reduction gearbox at the back of the engine where the power turbine drives, and then we've got an extremely thin-walled shaft here that keeps this drive shaft nice and light. And then at the front you can see the internal spline that the main rotor gearbox connects to, and you'll also see these lobes on the shaft. And what happens is, as this drive shaft is loaded by the torque of the engine, resisted by the aerodynamics of the main rotor, it twists. And we measure that twist. Each one of these shafts is calibrated, and we measure that twist to calculate how much torque the engine is producing in flight. And this shaft here runs within an outer reference shaft, which is also an extremely thin-walled shaft with an internal spline and then fixed lobes on the other end. And it's the difference between this unloaded shaft that doesn't twist and this shaft that does twist as they rotate together that gives us our torque measurement and our speed measurement on the GT50 engine. We've now produced prototypes of both of these components, and these are about to undergo their inspection to make sure that we've accurately and reliably produced the thin walls that we need to across the full length of both of these shafts. So those are your two primary drive shafts, and then of course the final part of the puzzle is the shaft that essentially provides the tail rotor drive from the main rotor. So this shaft is installed in this direction, so that is coupled to the front of the engine. This drives through the sprag clutch arrangement and straight down to the tail rotor. We've now made the third and final shaft that's needed as part of the GT50 drivetrain arrangement. So hats off to Craig and to the production team, Mick in particular on the shop floor, that's been working tirelessly to get these difficult components through the production development process. So let's talk about combustion testing. This is our combustion test rig, and as you'll recall from last month, we got a rig together and we'd done some preliminary trials showing that we could get ignition, we could get stable combustion, and we could run that through the startup phase of the engine operation. During that testing, we determined that there were a number of characteristics of the combustion process that weren't quite optimal. The combustion flame angle, the cone, was too wide and it was impinging on the combustion liner. So we needed to adjust that to make sure that we get the life out of the combustion liner that we need for GT50. In addition to that, we'd noticed some inhomogeneity around the cone, which indicated that we weren't getting uniform flow where we should be. We've done a bunch more analysis and identified what the causes of that were. In addition to that, we've made a bunch of upgrades to the rig itself. So we've now got a much larger blower to enable us to run through a much wider range of operating conditions. We've got a whole host of new instrumentation to be able to interrogate the findings and the test readings as we go through the process. A bunch of improved controls so that we can automatically control and instrument the whole execution of the test. And importantly, the things that we really needed to modify were the key characteristics of the development swirler and the development nozzle. So this is much bigger than the actual one that we'll put in the engine. We've made it simple for ourselves to be able to conduct the tests, but we have a nozzle in the center, and then a swirling body of air comes out to help contain the flame. as it burns and prevent it from hitting the side of the casing. So what we've done since we last spoke to you about combustion is essentially we've modified this assembly so that we've broken the swirler body into separate components, so we can now actively change the swirler angle and the key driving geometry of the swirl. So we can change the angle of swirl, we can change the mass flow going through the swirl live on test. So within 5 minutes we can update the way the swirler operates and truly optimize that for the whole range of operating conditions that we need for the GT50 engine. So we've done all of that. We've got the new swirling components manufactured. So an interesting point with this, there's a big move in industry at the moment to go and produce things using 3D printing to rapid prototype. It's actually the case that we can produce updated swirler components right here using conventional methods faster than we can send them out to a bureau and get the parts made. So these updated swirler components are made from the right material right here at DC1, and that's allowed us to rattle through some test iterations on the updated nozzle and swirler geometry much faster than we would have otherwise been able to do. And what a difference a month makes. Have a look at this for the latest test results that happened earlier this evening. So in the early trials, we had a very fragile and sort of chaotic flame that was far too open in the cone angle, impinged on the outer liners. And what you can see here is we've now got the striking, strong, stable blue flame. The cone's still a little bit too open, but we're going to adjust the swirler geometry using the kit of parts that we've got here to bring that back in, keep that flame front away from the combustion liner, and develop that strong, stable flame that we need to give GT50 the performance that it needs. Immediate next steps then, we're going to get the swirler updated to bring that cone in. Then we can do some further work on the nozzle itself and just make sure we've got the full range of operating conditions and good atomization so that we can relight it at altitude. And then all of the learnings from this go straight into the full combustor and get ready for the gas generator test. Really pleased with the progress on this. So the other key area of GT50 that's been developing at pace is our direct drive starter generator, the MGU unit, and its PMU control unit as well. Last month we updated you that all of the core internal components for the motor, the rotor and the stator parts had been produced or were in production. Over the course of the last month we finalised all of the interface components with the engine itself. So the casing, the sealing plates, the drive shaft that mounts the rotor itself, and the various other bits and pieces that go with it to complete the GT50 engine. All of those components have been released to production, and Mark and the team are now busily producing those. So very shortly we'll have a full set of 5 starter generator units to test. Now in terms of the testing, our test facility has now completed its acceptance testing over with the manufacturer. So this is the high-speed test unit that will allow us to drive the generator as a generator, and will also allow us to drive a rotating load when it's operating in motor mode, all the way through its operating range from 0 up to 50,000 RPM. That kit is now on its way to us. We had a couple of minor balancing issues to resolve, which we've subsequently done, but the kit is now ready to be sent over to us, and we'll have that installed in PC1, ready for PC1's opening. Welcome to DC2. Let's talk about the composites development that's been going on over the course of the last month or so. The main focus of work at the moment is production readiness, both for the release of the flight prototype tooling and fuselages, but also getting ourselves production ready for building these parts at scale. What you can see beside me here is the main focus of activities over the course of the last couple of weeks has been refining and improving our mold making techniques. So we've been looking at a conventional recipe of dry fabric and infusion-based molds and comparing that with some of the newer out-of-autoclave pre-preg molding solutions and some other novel mold making material solutions. This is one of our latest generation tail boom molds. This particular one has been infused, and we've been carrying out extensive vacuum testing on this over the course of the last couple of weeks. We have very strict vacuum integrity and leak rates that are necessary to be able to perform successful infusions and in general successful composite manufacturing full stop. This now not only meets all of the vacuum requirements, but we've got the surface finish that we need to be able to deliver a relatively pain-free paint process. So really pleased with how this has been coming together. In addition to the mold making developments that have been going on over the course of the last couple of weeks, we've also been preparing material samples for certification material testing and also the flame testing. So we've got a couple of test samples here that are waiting to be cut up into individual coupons for coupon testing. Those particular ones there are for the flame testing rig that we introduced to you last week. If you remember, part of the development that we're doing on the fuselage at the moment is looking at different ways that we can implement the firewall in the helicopter. We showed you last week the firewall test rig that we've developed, where we can hold both composite materials and also titanium and stainless and more conventional solutions in a flame retardant structure and then expose it to the required fire testing as necessary to qualify that for flight. So we've built the test rig, we've built the majority of the test samples now, so we'll shortly be able to execute the firewall testing to inform what the final firewall solution will be for the flight prototypes. So in addition to producing the test coupons for material testing, for the fire testing and getting the molds themselves to a production ready state, we've also been working on the paint processes that are going to be necessary to deliver the quality of finish that we require in production in full scale. We've now ordered the first of our production representative paint booths and all of the associated paint equipment to allow us to start developing out in detail exactly what we'll be doing to get these composite panels to the finished quality that you want to see on your helicopter. The paint booth will be installed directly at PC1, and what the guys have been doing behind me is just doing some more work on surface preparation on molds to get the finish transferring from the mold to the part to then make the painting process as simple as possible. Let's just have a look at this over here. You may remember our third scale model. One of the things that we're looking at the moment is some improved manufacturing processes for getting the internal details into the monolage. So what the guys have actually been doing recently to expedite the process is they've brought this old girl back to life and produced an external modelage shell, and they're now looking at a range of ways that we can fit the internal structure quickly and cost effectively in a much reduced time scale. So a lot of the things that we're doing here now are about accelerating the production process prior to releasing that final set of tools for the flight aircraft. So let's talk about the digital cockpit for a bit. We had a lot of really positive and constructive feedback from the two machines being exhibited at Duxford and then at Heli Expo. And we've been trialling some of the concepts, some ideas based on that feedback over the course of the last month. One of the crucial areas with helicopters, of course, is the vertical speed indicator. And as a helicopter pilot, we're predominantly interested in the low rates of vertical descent associated with avoiding vortex ring state. The problem being, of course, if you look at an implementation on either a traditional analog or most contemporary vertical speed indicators, the rates that we're interested in are actually very, very small on the overall scale, because typical helicopters can climb and descend at about 2,000 feet per minute. So one of the things that we've been trialing is looking at creating a non-linear range for the vertical speed indicator so that we can expand that crucial range close to the critical zone. Eric, why don't you take us through what you've been developing?
Sure. So we have a very early concept of a nonlinear VSI, and so I've just switched over to it now here. And basically you can see, so the value hasn't changed. So before it was right there, and if I switch it over, you see that the needle, the size and the amount of space and I guess granularity you have to be able to read the gauge at those areas closer to neutral, you have a lot more information that you can glean from it.
Yeah.
Now, of course, the drawback from it is that it's nonlinear, and so when you're flying and when you are changing your vertical speed, then the needle moves, even though you might be accelerating at a linear rate, or you know,
the needle will
the needle will accelerate, right? So I can illustrate that here. If I turn the simulator on, you can see the needle slowing down when it's up on the edges, because that's where the kind of curve tapers off, but then it goes quickly through the center range.
Through that range.
Right. So this is a very exaggerated sort of concept, but it was an early concept to just kind of test the idea. I think there's value in it, but I think we need to maybe flatten out the curve in the middle range, and then kind of curb it off on the edges.
Just soften the response so
Right.
people don't end up overreacting.
But overall,
Okay.
I think it's an interesting idea and has potential value.
Fantastic.
So we'll keep moving on that.
Great. Talk to me about airspeed. So
Yes.
at the end of last year, we moved the airspeed from the bottom to the top to improve the instrument scan and to keep it closer to your eye line while you're
Right.
flying. That's worked really well. But we've had lots of feedback that you still don't quite get the sense of rate of change of airspeed with just the progress bar.
Yeah.
Tell us about some of the options that you've been exploring off the back of some of the feedback.
Yeah, so the progress bar gives you, it does give you rate of change, and it does give you a kind of a positional reference. You do get some value at a glance. However, it's not quite as clear as a dial where you have an angle. When you look at the altitude and you see the needle straight up, you know you're going to be some multiple of 1,000, right? Or if it's straight down, 500, right? And so you don't get that with the airspeed. You don't have as much of a positional reference with just a progress bar. So I'm just going to switch this airspeed indicator over. All right, so I've just switched it over to this new concept, which is essentially an elliptical arc for the path that a needle follows. And it's very early stages, very rough. It still needs to go through the fashion department in a sense to get it cleaned up and refined. But if I just get things moving here, you can see that you have more of an angular change similar to a dial, and you have a little bit of a better glance value. And this is without any colors or arcs or gradients and that sort of thing. This is just the scale and the needle, and already I think it is somewhat of an improvement. So some ways to go on this, a lot of refinements, but this is the benefit of having a simulator. We can do very quick iterations with some of these concepts to test it out.
And don't forget, what we're trying to do here is fuse the best of old analog dials with what a digital cockpit can offer, and that's precisely what we're doing here. So that's great stuff. So one of the things that you've also been doing over the course of last month is to take a tablet-based implementation of the DigiCockpit hardware. So our screens coated, backlit with our processes, our DigiCockpit implemented on there, driven by our graphics boards, and take those, sit that on your lap in another aircraft and go flying with it and have a look at how these screens perform during normal flight operations. So why don't you tell us a little bit about that? Firstly, how did the screens perform?
Yeah, the screens performed great. The brightness ranges were acceptable with both the high end and the low end for making sure it's bright enough in the day and dim enough at night. The glare and the reflections were good with the coatings. I was happy with that. And this general size and the position relative to the eye point and the readability of everything, it all passed the test.
So font sizes and contrast, all good, easy to read.
Yeah, there were definitely some areas where we learned. For example, my assumption going into this was that the highest contrast areas, as in like as bright for the text for the foreground and as dark for the background to obtain the highest contrast, that would result in the best readability. But the takeaway was that isn't always the case, because if there's reflections, you see the reflections more in the dark areas. And so it's actually better sometimes to have a brighter background, reducing contrast essentially, but better readability because you don't see as much of the reflections.
Fantastic. And so that's great, and that worked really well during the daytime. Reflections were well managed by the coatings. How about your ability to actually use the touch screen when you're bouncing around in a helicopter? Although the majority of stuff will be done on the IPI, was the big touch screen still usable in practice?
Yeah, it's still usable, especially since we're planning on having a rest where you can rest your hand so that you don't have your whole arm moving around. You can rest your hand and then touch, and all of the touch regions are intentionally placed. All the main touch regions are placed either on the bottom or the left edges of the screen, so you can rest your hand on there and touch with your finger.
Fantastic. So one of the things that we haven't showcased yet that we also tested during those trials is our night theme. So obviously the very bright, high contrast stuff is necessary during the day, but at night that's somewhat overwhelming as you demonstrated during the trials. What have we done about that?
Yeah, so at night this color scheme is too bright, especially with the artificial horizon and some of these bright highlights, and so we're experimenting with the concept of having more of a dark theme, dark mode, where the bright areas are reduced. There's less contrast. Everything's fully readable and clear, but it's just not quite as bright for use in night flying, and that's been a success. These are just some early concepts here that I'll flick through. It's all just in the design stage at this point, but
and of course it looks great, but unfortunately you can't use that during the day because it's too dark during the day, isn't it? So you'd just be dominated by external reflections.
Yeah, I think you might potentially be able to use it during the day, but it's not as good. Not as good for the reason I described of the very dark background with it. You see more of the reflections. So, but on the reflections, I want to note that the coatings we have in this laser were excellent. And so it's really not that much of a problem. You just see it's all blurred out, and it does a really good job at that.
So it's working as designed.
Yes. Yeah.
Fantastic. So this was also your first time flying with one of our 15.6-inch screens on your lap in the right position relative to its mounting in HX50. Now, one of the concerns that we sometimes get from customers and prospects is the fact that that's a big blockage right where you need to see. Did you do any confined area work, and have you seen whether or not this is going to be a problem?
So we have some concerns with especially the final stages of confined area approaches where you have a really steep angle and you do have an obstruction there. There's no way to avoid it. So we have some more tests we want to conduct with also some additions of some pass-through cameras, having a camera in the nose looking forward and down, that you have that feed coming through in the display. That would help.
So just use that as a background to the instruments.
Yeah, but by and large, the obstruction wasn't an issue for all modes of flight except for that high angle approach.
Yeah.
But the camera hopefully will add some visibility in that range.
And we'll be talking later about some of the lighting trials, or we spoke earlier about some of the lighting trials that we've been doing for the external lighting system for HX50. One of the other threads that you've been developing, of course, is the use of enhanced vision systems as backgrounds for DigiCockpit. Right. Do you want to just let us know where you're up to with that?
Sure. We've got some candidates for some infrared cameras, night vision cameras that we can use to basically do essentially the same thing, a pass-through feed onto display, just with a camera that works at night, right?
Yeah.
And so the idea is, can we improve the situational awareness and safety of the pilot at night flying by giving you at least some indication when you're high up and you say you have an engine failure and you need to identify a place to land, you need to have some way of choosing a suitable direction to go for a landing spot. And most of the time in VFR night flying, you don't have that. You just see blackness, right?
Yeah.
And so with some sort of infrared camera, you might get some of that texture where you can distinguish between a field and a forest, which you wouldn't otherwise be able to.
Fantastic. So one of the final things that you've been looking at over the course of the last month is a minor rework of the stick heads on the Cycling Collective. Now, for the majority of people, they'll be aware there's things like landing lights, hydraulic switches that will always have to be on the stick heads. But the way we'd arranged the original button packs on here, plus and minus for frequency presets and a flip mode, all those things are really predisposed on how radios and things used to work. So just talk about some of the things that we're looking to experiment with on the stick heads to better interact with a truly modern VFR digital cockpit.
Sure. So, like you said, some of these switches, we're still trying to assess the value of them. Some of them are very clearly valuable, like the frequency swap button and like autopilot off and that sort of thing is important. But like the plus and minus buttons, we're still trying to assess whether those are actually going to be valuable. We might switch them out for something that has more value. One idea we had was having like an alt key similar to what you have on a keyboard, which would engage an alternate palette on the UI in certain areas for you to get to
like shortcuts.
Like shortcuts, basically, and alternate functions. So that's just one idea. So we're looking at options and trying to figure out the best way that we can use that space and use that instant access with your thumb or whatever, with fingers on the controls to do certain functions.
Fantastic. Thank you very much, that's great. So that brings us up to date with the DigiCockpit developments. Let's head over to PC1 and see how our latest production facility is shaping up. Another big focus of our attention over the course of last month has been our preparation to move into PC1. Clearly, there's a great deal of work involved in pulling out all of the facilities from DC1, DC2 and DC3 and then carrying out the vast amount of enabling works that we need to do in this brand new unit here, PC1. So if I just take you through some of the things that we've been dealing with over the course of the last month or so, the big one being the brand new machine foundation for our gantry mill. The gantry mill is the new facility that we're building to support our next generation composite manufacturing facility. This is the machine that's going to build all of the composite patterns, all of the composite molds, and a lot of the crucial tooling for all of the composite work within the company, not to mention trimming final fuselage assemblies and also trimming all of our polycarbonate and acrylic window panels. So this machine is crucial both to the remainder of development but also to our production facilities as well. So in order to get the gantry mill installed here at PC1, then we've had to excavate a 14 by 15 meter base out of the one corner of the facility, remove the standard factory floor slab, excavate down, remove all of that material, and then build a 750 millimeter deep bespoke designed machine foundation. And the purpose of this is to physically hold the machine rigidly enough that over the span of that 15 meter base, it's able to maintain enough rigidity and stiffness to hold the tight tolerances that we need to produce patterns, molds and parts to extremely tight tolerances over these vast distances. So once we'd excavated the base, all of the new rebar's gone in, all of the new concrete's been poured, we've set the new base, and then just at the moment we've got the sealant going off ahead of the rest of the floor being coated over the next few days. In order to get PC1 ready for production, there's much more to do than just getting the big machine bases in place and the various other enabling works that we need to do. Before we can really move any of our infrastructure in here, we need to get even things down to the floor just right for precision engineering and manufacturing. Over the course of the last few days, we've had our flooring contractors in here shot blasting the whole floor. We've got to wait for the dust to settle, and then over the course of next week, the whole floor area will receive a high-grade epoxy coating so that we've got a clean and easy to clean surface on which to be able to carry out aerospace-grade manufacturing. So with the new gantry mill's machine tool base cast down into the ground, with the whole factory floor coatings going down over the course of the next week, we'll be shortly starting to install the gantry mill. That happens around the middle of next month. But as you remember from the gantry mill work you've seen us do at DC2, this is an incredibly dusty process. Working in materials like carbon fiber, the carbon dust, the model board dust, and trimming all of those sort of pattern making, pattern building materials creates huge amounts of fine dusts that have to be properly controlled. The new gantry mill is a fully contained environment, so none of that dust can escape into the broader production facility. And in order to then keep the internals of the gantry mill clear of dust and to process all of that, we're installing a industrial scale extraction unit from the machine outside. So let's go and have a look at the machine base that we've put in out here, just so that we can get that stuff installed also. So all of the dust is extracted from the volume of the machine, brought out through the factory wall, and then on this new concrete pad that we've installed here, we've got a unit that collects and compacts and then essentially palletizes all of the waste material ready for responsible disposal afterwards. So all of these little details have to be done before we can get into PC1. So all of the other fun things that Mark, Bruce and the PC1 development team have been getting on with over the course of the last month, all of the other crucial enabling works that we need to complete to be able to get into production here at PC1. So one of the key tasks that we have to get done first, of course, is routing all of the electrical power around the production facility. When you take possession of a new building like this, the power comes into the building, but that's about it. It's up to us then to lay out our manufacturing facility and route all of the crucial services around the building that we need to. So over the course of the last month, the guys have been laying out the proposed factory layout, the proposed test rig layout, and all of the things that we've got in store for PC1, and then routing the critical infrastructure like the cable trays, the switch gear, the sockets, and all of the other infrastructure that we need, the local distribution boards and things, getting those installed in here, ready to receive the machine tools. Similarly, we've had to install our own bespoke lighting to suit our specific applications. So we've got half of the lighting in the port side of PC1 at the moment. The rest will be going in over the next couple of weeks. We've had to install compressed air, so the compressors are being moved over here next week, and we're getting the compressed air lines and all the control circuitry for that installed around the building. And then once we've done that, we're then into the install of the mezzanine floor. So if you remember from when we developed DC1, then it's vital that our machine shops are temperature controlled. If you're going to hit the kinds of tolerances that you need to be able to produce gears and bearings, then we have to hold the machines, the materials, and everything in that process at really tightly controlled temperatures. Now, in order to avoid having to temperature control the whole facility where it's not needed, we're building a mezzanine floor over the machine shop. So the mezzanine floor has now been designed, and that's scheduled for installation over the next month or so. That then provides a lower level roof where we can install the climate control system that we're bringing with us from DC1. The climate control system has now been removed from DC1 and is in transit over here. That will be installed in the mezzanine section that's being added at the moment, along with all of the necessary fireproofing, lighting and other containment systems we need to keep that machine shop under the precisely controlled conditions that we absolutely need to produce high quality, precision aerospace parts. Now, once we've got all the serious engineering stuff done, let me show you where the customer lounge and the showroom's going to be. Over here, this is where the office suite is built on a mezzanine level. This undercroft at the moment is just being used for storage while we process all of the work that we've got to do on the floor and the enabling works around the rest of the facility. But once all of that stuff's done, this area will be cleared out, and we're building a customer reception and customer lounge here, coupled with a showroom for both of the aircraft that we built and displayed at the end of last year for you all to come and see and experience for yourself. So the enabling works at PC1 have gone extremely well over the course of the last month. We finally got our new machine base in. We've got the enabling electrical works and compressed air works going on at pace. The lighting system is in. The new floor is about to go down so that we can finally get the mezzanine floor in there, get the machines moved out of DC1 over to PC1 and get the gantry mill installed along with its crane ready to start the remaining phases of development and then production. In addition to that, we've been moving on at full steam across the development program. GT50 is coming along really nicely with exceptional progress on the compressor, the turbine, blade casting, big castings, and then the DigiCockpit has been performing wonderfully both in the daylight and night trials that we've been doing. Cracking progress from around the program. I'll pause for a moment now and we can get started with some questions.
Wow, Jason. Another action-packed update. Really exciting to see how many different things are going on, both in the development centers and the new production center. Thanks for taking the time to give us that update. And we've got lots of questions that are coming in. For those that haven't posed their question yet, I encourage you to put that on the chat, and we're going to be able to ask those questions to Jason in just a minute here. So I'm going to start with the first question from Steve, and it's a great question. He's asking, when testing components, say the impeller or different parts of the aircraft, what typical things would you do beyond the initial envelope testing? So examples would be operating to 5 times the RPMs, or operating at 2 times the temperatures, or up to failure, different things like that. Can you give us a little overview?
Yeah, it's essentially you take the components all the way to the point of failure. So we're looking for the fastest it's ever going to spin, and then we have some margin on that, and we establish what the breaking point is. We're looking for the highest temperatures it can ever operate at, and we're looking at conditions where the component is operating with flaws in there of given sizes as well. So we're trying to make sure that we are making sure that we understand every conceivable way that the part can be abused and damaged, and where the limits are in the real world, and that applies to absolutely everything. So anything on the aircraft that's flight critical, whether it's the engine, whether it's the flight controls, the structure, everything will be tested to destruction. We know exactly where everything will fail.
All right, that was clear. And Enric is asking about the heli simulator. When do you think we'll have an HS50 full simulator?
There's not really an update in that from last month. Essentially, the math model is there and established. We're doing some updates at the moment on the latest production version of the fuselage, which will influence the aerodynamics, and we'd like to wrap those things up into the model that we release. But essentially, the math model's available, and so it's over to you guys really to just update on where the X-plane and the flight sim models are. So the math model from us is stable now.
Yeah, absolutely. Just to touch on that.
Yes, go ahead, Michelle. Go ahead,
yeah,
Michelle.
we had a good conversation about that with Jason actually not too long ago, about when the right timing is to be able to bring the simulator out. And we want to be able to bring something that is as realistic to the actual flight experience as possible. And so for that, like Jason's saying, there's final updates with the flight dynamics and the way that the new airframe is going to interact with that and so forth. So we're going to wait a little bit longer before we start integrating that model with the X-plane and then Microsoft Flight Simulator and so forth. So it's coming, but just be patient for it, and it will be here before not too long. So next question is from Charles. He says, what training will be put into place before pilots and technicians?
We cover this. We've covered this several times. Really, essentially, each aircraft that's sold comes with a type rating course. So it's your responsibility to get qualified first. But we'll then do a type rating course when you're at the factory with us. You can bring a maintenance technician of your choosing. So if you're a guy that's already got a helicopter, bring the technician that you choose and we'll give him his type rating to maintain your helicopter for you. And then there's a safety course as well that feeds into our active safety management program, where the flight data recorders and the various technology we've got on board the platform are coupled with our training programs and the monitoring systems to ensure that you transition into our fleet safely.
Carl always brings us a good technical questions. The next one is, how far below critical cyclic loading will the twisting shaft undergo to prevent fatigue failure?
That's a very good question. Again, that's subject to very detailed testing. So the fatigue life on all critical components is very, very conservatively calculated and then tested all the way to destruction. So we have a significant margin on top of the cyclic life required to make sure that we're well within the fatigue limits under all operational conditions. So a very long way.
Very good. And Brian's asking, can you give us an update on the schedule? So first flight, first build, etc.
Yeah, so there's no change to the advertised schedule at present. A lot of the things that impact that are the things that we're doing right now. So the move over to PC1 is on the critical path, so it's important that we get in there as soon as possible. An interesting point to note is this last week we stripped out all of the air conditioning equipment out of DC1, so we can't currently make gears and bearings until we get into PC1. So we've got to execute that program effectively to stay on track. But aside from that, the rest of the program is running as advertised. We'll continue to update you as the program develops, but as we stand at the moment, it's as we've said previously.
If you cannot get to the production numbers you want with the GT50 parts, will you add machines to keep up with your production estimates instead of extending delivery times? About the GT50, I think it's talking about the whole helicopter.
It's talking about the whole helicopter, yeah. So the factory, our production infrastructure is designed to make 500 helicopters a year in the first year and then scale towards 1,000 helicopters a year. Beyond that, I have no intention to increase the production volume for a single model because I think the longer term demand won't exceed that. So we will add all of the infrastructure necessary to keep to that production schedule, and the beauty of being vertically integrated, the beauty of making all of these mechanical components yourself, is that fundamentally the main part to scaling for the mechanical bits is adding more machines. So we can do that very quickly and very simply. So yes is the simple answer to that. We'll add the infrastructure necessary to hit the production volumes.
Awesome. And Carl's asking another question. Is the method of measuring torque using a twisting drive shaft used in other helicopters? I know that it's not in the Rolls-Royce RR300.
Yes, it is. It has been used before. It's a well-established and well-understood method.
Okay.
Okay. What is the current timeline for having a fully operating GT50 engine on a test stand?
So again, that remains unchanged at the moment. We're aiming for the gas generator to be running at over the summer, and then we'll build the rest of the modules up in the subsequent months after that. So the PMU components are due end of this month, early next month, and we'll get the starter generator built at that point. We've got the first combustor waiting for the final couple of parts before we can pull all of that together. You've obviously seen the combustion nozzles and swirlers on the test rig over there. We're building the components for the gas generator at the moment, and then we'll get that on the rig. And then the only thing that remains after that is the transmission and the drive chain, which will follow shortly after. So we want the gas generator running as soon as we can over the summer, and then we'll build it up module by module as we go through those tests.
Great. Robin is asking, will there be an upgrade path for the HX50 to HC50?
No, assume there won't be. Fundamentally, there's owner involvement in the HX50. So although they're identical aircraft built in the same factory with the same production approvals, you won't be able to change an X into a C.
Will there be a breakaway system if the generator fails and binds so the engine can still run?
Yes. Yeah, the shaft is, if you have a look at the, I should have put a slide in really, if you have a look at the stub shaft that drives the starter generator, it's very slender, and that's done for a number of reasons. It's done so that the starter generator, if that was to seize, would shear the shaft and allow the engine to continue to run, but it's also done to decouple the rotor dynamic modes of the gas generator rotor itself from the starter generator, so you don't get any nasty structural dynamic couplings there.
Excellent. And Martin is asking a great question, actually, which I think lots of people are probably wondering, and it obviously deals with the move to the new factory site. He's asking, is it possible to arrange a factory visit?
It certainly will be, but not right now because the whole place is a dump. So at the moment we're stripping DC1, DC2 is still operational, but DC3 is a storage ground, and PC1 is full of contractors every day of the week. So if you let us get moved into DC1, into PC1, the schedule for that is that we should be in as a team by the middle of June, and then the works that we've got planned in this first wave of installation should be finished by about the middle of July. So I think the current plan is that we'll be opening the doors to tours again in around August. So we will be opening the doors again, we will be welcoming customers, but if you could just be patient for a little while because it is chaotic and you wouldn't see us in our best light at the moment while we're in bits. Let us get moved and then we'll welcome you with open arms.
Excellent. Good. And just to be clear, we have been doing actually tours since the beginning of the program. And we're going to resume that, as Jason said, but that's the part of the culture of the company. So everybody's welcome. We're going to be opening up those slots soon, as Jason said, and announcing that, making that public, so you'll be able to register for those tours.
I think before you go on to the next one, Ruben, the other thing to say, of course, is everybody wants to see the helicopters. Our helicopters have only just cleared US customs, so it's going to be about another 5 weeks before they get back to the UK. So again, August is about the time that we'll have those in the factory and back together again by the time we've done everything else that's involved. So if you just plan on August and beyond, then you'll have a lovely experience when you come see us.
Excellent point. Are there plans for a bare bones version of the HC50? No, I think he's confused about the model. But basically, will there be a bare bones version for the helicopter for utility clients who don't need all the luxury features?
Yes, fundamentally, one of the things that Henry's working on at the moment is a stripped back interior for more utility focused C models. So HX50 has always been a private owner machine, so the kind of VIP interior comes as standard, but that will be one of the interiors that's available for the commercial model. You strip all of that back, save a little bit of weight, and you've got a bit more of a utilitarian and hard-wearing interior. So yes, I can't give you any details on it because we haven't done it yet, but it's in progress at the moment. There will be a utility interior.
Yeah, and one thing to add to that before I ask the next question is one of the nice things is that all of the seats can be removed other than the pilot seat. And so if you strictly were doing something that was pilot only operations, you could take the other 4 seats out, and there's a fairly substantial weight savings with that as well. So that would be one simple way of kind of configuring it to save some weight as well. But the next question is, will you allow pilots to choose between different color schemes on the main screens? So on the HTC.
I think in the fullness of time, yes. Certainly in the X model, we'll build in a degree of customization, and some of that will be themes and skins as you would have for your automotive products. At the moment, we're entirely focused on minimum viable. So we've got the normal daytime theme, which is, as we discussed in the update, is focused on daylight readability. And then we've got the muted night scheme for night VFR flying, which is just all based on appropriate contrast and color palettes for night flying. We can jazz that up a little bit for different operations, and we've got people that prefer more traditional look in the instrument arrangement as well. All of those things will be addressed in due course, and it is of course just a software update. But for now, just expect the standard look of the system. There is some customization features that we're working on, but they're modest, and you'll just have the 2 palettes for day and night flight.
Another question from Carl. Oil pressure, voltage, amps, all still seem to be white numbers. Can you make them show range so we know how far from limits they are? And can you make them green when good and yellow and red with not so good?
So we could do that. but we're looking at an alternative way of doing that, where we use animations, we use dynamic responses in the screen to do the same thing. If the thing if white is normal, then that's normal, just the same as it being green. You only need to know if it's drifting out of that range, and we can do that with color changes at that point. So we've got two versions of those gauges. We've got a version that does show some ranges, and we've got a version that uses animations, and I'll share some of those things on the app, because Eric and the design team have been working on something like that. But the design concept for this is very much to make the flight instruments as clean and as simple as humanly possible. I want the least amount of information on there that is necessary. So that what we've got at the moment is consistent with that. There are alternative ways of doing it.
Okay, and the next question I think is quite similar. See if you can read anything different in it. It might be talking about the other gauges as well. It says, I think it would be great if you could show numbers. The numbers provide hints. Green numbers are good, yellow nearing the warning levels, and then red would be a critical item. That way you have the exact data, but also a visual warning.
So that's exactly what we do. If you look at the power indicator, for example, you have the number. The whole gauge will go orange when you're in the transient range, and red when you're approaching your absolute limits. You get a pop-up countdown timer in those colors. So in the ambient range, you get your 5-minute countdown timer, and then when you go into the red range, you get your 30-second countdown timer. So we do all of those sorts of things. We haven't done it yet, but when we've nailed exactly how we want to improve that vertical speed indicator, there'll be combinations of vertical speed and airspeed that can trigger color transitions as well. But again, it's about where you pitch that stuff. You don't want it to end up looking like a Christmas tree. It has to remain intuitive and simple. But of course, we have infinite possibilities with a digital display.
All right, will you allow third-party access to the display? So for example, if I had an externally mounted camera for filming, it would be great to be able to patch it through to one of the screens.
Yet there are plans in place for that. We haven't done anything about it yet, but camera feeds for things like aerial filming in commercial roles, a downward looking camera for your sling loads and operations like that, the night vision stuff, electronic news gathering, all of those sorts of things. That second screen is very much a candidate for all of those systems, so the architecture will support it.
Great. And what is the shipping progress of the gantry mill?
It's sat in storage in the UK waiting for us. It's been here since before Heli Expo. The limitation was getting the lease signed on the production facility, and then getting the foundation design done and approved by the landlord, and then doing the work, and then waiting for it to cure, and then getting the floor in, and then getting the power and the air into it, and then we can install it. So it's here, we own it, it's sat here waiting for us. We've just been waiting for that pad to go down.
Great.
Excellent. And when will the certification process start?
The certification process is a very long process, and it has already started. It's been in progress for a number of years now. So it's not you start it on day one and you finish it on day zero. It's a long list of activities that start with internal process development, design approvals, production approvals, organizational approvals, appointment of key staff within those organizations, and then going through both the type approval for the permit and the type certificate for the certified version. And we're on that path already, have been for years.
Great. And when you relocate the machines and the tools to PC1, do you need to requalify the manufactured parts?
We need to do an awful lot of work on each of the machines. So moving these machines is actually a very big deal. So a lot of these machines receive very special calibration so that we can do things like gears and bearings on them. And all of that will have to be repeated when we're in PC1. The machines will also need to be left to reacclimatize once we've got the climate control back into the new machine shop. And then yes, they'll all have to be recalibrated before we can use them. We won't need to requalify them in a certification sense, because they're not qualified at this point anyway. So we'll wait until we've finished all of the development and we've nailed down the detail of the production processes we want before we lock that in. Otherwise, you're just creating more and more detail and bureaucracy to churn while you're going through development.
Oh, this next one is interesting. Can we fly into PC-1 when it's up and running? Do you plan to have helipads there?
Oh, this is a...
How much can you say about that?
So, we are trying to get a helipad approved for PC-1. It is unlikely that customers will be able to fly in, but company pilots will be able to fly in. I'll update you more on that. There's an active approval process going through with the CAA at the moment to get landing facilities at PC-1, but it's complicated because it's within a congested area, and obviously we're predominantly concerned with single engine helicopters, so I've got to let that process run its course before we know where we stand with that. But I'm all over it.
Excellent. It says, will you have a hub in one of the near areas around Las Vegas, Nevada area in the United States?
What do we mean by a hub? If we mean a service and support center, then absolutely. There'll be a global network of service and support centers. It's one of our big activities for this year to define exactly what that looks like, and then to start inviting people to come and apply for those to be part of that network. But we haven't done anything about it as yet. We're still defining what those requirements are.
Okay.
Will you fit a similar turbine, size and weight to your HS50 to complete certain tests while GT50 is being developed, like stress, crash tests, etc.?
So what's the question? Would we fit another manufacturer's engine to HX50?
Yeah, exactly.
No.
Yeah.
It's really not as simple as that, because the way you mount the engine, the way you feed air to the engine, the way it integrates with the firewall, all the control systems are totally different on GT50 to other engines. So it would be a massive re-engineering program to accommodate another engine to then throw it away and then put GT50 in. So there's a lot of test and qualification work that needs to be done on HX50 on the ground on test rigs before it needs to go flying. So we're not going to be short of work to do on the airframe while we're maturing GT50. Don't think for 1 minute that that'll be a bottleneck. It won't be.
Okay. And the same machine, right? So see, the turbine and the airframe, they can't really disconnect. This is just the same, right?
Yeah,
it's not something you just module and buy out of the shelf, right?
Yeah, it's like popping your heart out and borrowing somebody else's. It doesn't work like that.
Exactly. I'm going to ask the next question, and then I'm going to go right on to the next one, just because I think the next one will be quick. It says, is Tesla coming out with an electric helicopter too? So that's the one question. And then the next one would be, is the factory in Creswell still planned?
Is Tesla coming out with an electric helicopter? Not that I'm aware of, and if they are, I'd love to know what batteries they're using. And is the planning application is still going through at Creswell. At the moment, that process has stalled. And so as we announced at Christmas, we're planning to expand our rented space to get us into production without the obstructions of planning permission, and then do the flying at a fly-top space at a local airport. We will still homogenize everything to a global headquarters, but that might be a little bit further into the future now. We need to get into production without the delays of planning issues.
But actually, that's a great solution for flying-in clients, because we're going to have the flight testing site, and obviously clients will be able to fly there. And there's going to be a hill facility there, right? So that's going to be also able to accommodate the flight, and then probably a very short commute to the factory, to the location. All right.
Yeah,
go ahead.
There are plenty of places to land fixed wings and light helicopters very close to PC-1. So getting to PC-1 for people that are visiting, if you want to fly, won't be difficult.
What's the range of cabin angle between stationary flight and the higher end of the airspeed range?
Very, very little. So at the moment we're sitting at about 1 to 1.5 degrees nose down at cruise speed. And the reason for that is twofold. We've got a relatively large forward mast tilt angle in HX50, so people traditionally use about 3 degrees. We've gone to 5 degrees to ensure that we've got a level cabin attitude at high speed forward flight, and the minimum possible amount of blade flapping relative to the mast to minimize vibration in forward flight as well. So this machine has been set up to be a get you places helicopter. What that means, however, is that in hover in a neutral CG position, you'll be about 5 degrees nose up. So you're looking at between 5 and 6 degrees difference in cabin attitude between the two extreme conditions.
Okay. And can you give us an update on where you are with the CAA, FAA regarding heli certification in its class, yeah.
As I said originally, the whole process has been ongoing for years. So we're in the process at the moment of working through our design organisation approval and then the production organisation approval. We're developing through our cert plans and qualification plans for every element of the helicopter, and then that will go through the CAA first, and then once we've got agreement through the CAA, that will be rolled out to the other authorities once we've set the precedent. So that's a key activity for this year, is we need to push that, we need to accelerate that a little bit now. But again, it's a cart before the horse thing. Until the program is in a sufficiently developed state to go and engage them, it really doesn't benefit us as an organization to do that too soon.
Very good. So excellent. The next question is excellent to clarify the build school process. Should we expect to come to the factory for 2 weeks to build the HX50, and then several months later expect delivery? How many months?
Sorry, say that again, Ruben. You broke up. I didn't.
So yeah, should we expect to come to the factory for 2 weeks to build the HX50, and then several months later expect delivery? How many months? We need some clarification here of the build process, build school.
So okay, so you come to the build school. You spend 2 weeks with us working alongside our staff on the construction of your own helicopter. At the end of that process, your aircraft is flight tested and given its approvals, and then it's ready essentially then to be broken down, if it's going to be shipped, to be broken down, ready for shipping. How long after that you receive your helicopter depends purely on where you are in the world, and whether you're flying it to London from here, or whether you've got to get it all the way back to Australia or New Zealand. So the rest of it then is just down to how long it takes to ship by whatever means you choose.
Excellent. And then are you planning to sell the GT50 by itself? Maybe to put it into other aircrafts? Maybe we'll fit it into anything?
Absolutely not, no.
Okay.
Okay, Stephen is asking, at your new site, is there a runway for small private jets? Need to clarify those two sites again.
Not at there isn't at PC1, but there is plenty of facilities local to that, so yeah, and then it's a short commute from those facilities to PC1.
Okay. And Charles is asking, will there be utility models applicable for military and paramilitary?
So again, there will be utility models. We'll have a standard range of products that are available to anybody that's qualified to buy them. I don't at this point intend to target specifically military contracts, because they tend to be very bureaucratic, and they'll push the organization in a direction that will naturally move us away from being able to produce low-cost helicopters for the civil market. So the civil market is really our core area of interest. If a military system integrator sees an application for our product and they're prepared to take the product, then that's fine. But we're not going to get involved in big military programs. I think that would take us in very much the wrong direction, and it isn't the sweet spot that we're looking for.
If the new helicopters owners need, like myself, 4 pilots available with 2 or 3 aircraft and helipads ready to go in a 24-hour shift, do you prepare pilots with courses? So basically, the question is about what type rating does the factory provide to whatever operation?
Yeah, so yes is the simple answer, but our role isn't to displace people that provide flight training services and people that provide pilot services. That's not
Display
what Hill
or
Helicopters does.
compete probably is the word, right?
Yeah.
Probably compete.
So
it's not compete.
in the early days, clearly the factory is going to have to play a pivotal role in training early examiners, early instructors, and qualifying as many commercial pilots as we possibly can to make sure the fleet is supported as it rolls out around the world. We do intend to provide extensive support in terms of the quality of training materials that are used for our type rating courses around the world, and flight training that's done, ab initio flight training that's done on our aircraft, really to try and raise the bar on the standard of flight training that's conducted everywhere. So we'll provide all of the support necessary to make sure that pilots are available. The other thing that we will be doing as well is, many of you will know, we have a Hill app, which is predominantly a customer app, but that app will grow to provide the interface with your aircraft, but it will also provide a portal for you to access all of the support services that you need through the Hill network, so the service centres, people that operate services based on Hill helicopters, and then also almost like a dating agency for pilots, where you can go and find a pilot in your area that meets your operational requirements as quickly and effectively as possible. So we'll make it easy for you to find pilots, examiners, instructors, mechanics and service providers wherever you are in the world through our portal.
Very nice. Steve Buchan always likes to ask the fun questions. So as the question says, a little fun. Do you expect to be releasing any holiday light show models?
Holiday light show models. Steve, for you, I'll release anything you want.
A little software upgrade for Steve, you know?
Yeah.
Yeah. Very good.
Okay, next one is, how much cheaper will the utility version of the HC50 be? Discount for utility.
I don't think I would see it like that. Our interior isn't expensive in comparison to what you'd expect a VIP interior to be on top of a conventional helicopter. So the commercial interior will just be a different type of interior. We've still got to make it and fit it. So I wouldn't expect it to make the aircraft cheaper. It'll be a different set of equipment.
Okay. And will the autopilot be able to fly an instrument approach with ForeFlight?
Not initially. But we will be releasing an IFR version in the future, so at that point it'll be able to provide full instrument flight capability.
Okay. Do you intend to charge $1,000 for the heated pitot tube when AC is included? A bit confusing here, the systems.
Then,
you probably need to clarify the different.
So the basic pricing strategy with HX50 is that the base model provides everything you could realistically want and need as a private helicopter pilot. Beyond that, the operationally the specific operational equipment is priced to be competitive with other manufacturers out there in the market. So if you want to spend more and fit more, you can. But the base helicopter should give you everything that you need. And remember,
Jason, is the pitot heat pitot tube heat related to AC? Because
no,
it seems to be a connection of the question, but it's not related at all, right?
No, I think it's the fact that traditionally certified air conditioning systems for other helicopters were hugely expensive upgrades. As isn't, it's standard. And so I think he's looking to scale the price of a pitot heating system in a similar way. But you've got to remember every helicopter gets the aircon system, so we have the volume and we have all of the processes installed to bang that out on every machine. As you get into the specific roll equipment, then we don't have anything like the volume with that, and it's an offshoot on the production system. It's a different it's different to a basic standard helicopter.
Why do you think the
Very good.
AC was that expensive for other models? Why do you think that was justified? Well, actually, it is a fact
So-
that the AC is quite expensive in other models, other
Yeah,
manufacturers.
So I think that to be kind, the response to that would be it's a very small market, right? So somebody has had to develop an air conditioning system, do all of the approvals for it, and then amortize all of those costs over a very small number of sales. So if you look at the systems for helicopters, other than the market leader that sells in reasonable volumes, then these are all tiny volumes to try and amortize a development cost over, and all of the associated liabilities and things like that. So I think that's a very significant reason. And then of course there's the straight commercial reasons as well. You want it, where else are you going to buy it from? So there's two factors there. So for us, we've pitched HX50 and HC50 as a leveler. I've built the helicopter I wanted, right? So I've built a machine that's got what I believe to be the right specification at the right price point to bring general aviation back to life again. And everything that's part of that standard configuration, we've got the economies of scale of now building these helicopters in similar volumes to individual supercar manufacturers. So we can get to those sort of price point levels.
Yeah, that's really good. And just to add to that, I think the other factor is some of these other aircrafts don't have the same weight margins. And so to add AC as standard on some of these aircrafts might be prohibitive, and especially in certain climate areas and so forth. And so they add it as an option. Obviously, they're going to charge what they need to for that option as well. Whereas for the HX50, you sort of build that into the base spec of the aircraft to be able to still offer the performance that you have, but to have AC as just a standard part of that operation.
Yeah.
Charles is asking, which areas of the design are yet to be locked down?
So as I think I mentioned in the update, we're building in a whole host of updates to the final production version of the main structure at the moment. So there's still a degree of flux on that. So once we've frozen that, we can then release the tools and get that built. And there's a few areas of the main rotor transmission and the rotor head that we're working on at the moment. So there is still a reasonable amount of design detail to be finalised. And the big area, of course, is we haven't done very much on any of the optional extras. We're focusing on the core elements of getting the aircraft into flight at the moment. That's what's receiving the greatest amount of attention.
Mm-hmm.
Excellent. Next question is about servicing, and it is like this. How do you re-inquire on operating a service and support center in the US? And I just want to add here, Jason, could you explain a little bit what's going to be the strategy of the company of implementing service centers and selecting them, and what would be the criteria? Because we have a lot of applications, we have a lot of interest. Usually in the daily presentations, we have some people also coming with that interest. And the other day we were discussing, Misha and I, with Peter, about the great strategy that Hill is going to be implementing of having that brand. The Hill brand is going to represent much more than the service center. It really is part of the culture and the process of selecting and making sure that when you see that Hill brand, it's going to be serviced in the Hill way. Can you explain a little bit that strategy and what are you planning?
Yeah, so one of the serendipitous things that came out of what we've done here is this amazing community of people that we've built through the HX network and now into the HC network. And what we want to do is make sure that we continue to serve all of those customers throughout their ownership journey to the highest possible standards. So we want you to be able to access support from a Hill service centre or any of the services that are provided on our helicopters wherever you are in the world, and for it to feel the same. But with the little local cultural nuances that make it appropriate for the area. So what we're doing at the moment is developing a set of requirements that reflect the values that we want the service centres to deliver in supporting customers. How we integrate that with our app and our online services, and how we integrate that with stuff back at the factory, and then that set of opportunities will be offered out to anybody and everybody that's suitably qualified out there in the field. So there are lots of amazing organisations that already do great work in the helicopter business, and we have no intention to displace them. We'd invite them to come and be service centres, but it will be with our minimum set of requirements to deliver this proper luxury feel, this proper high-end customer support, so that everything that every touch point with the company is totally top drawer. And then one of the other areas that we're looking at is this network of organisations around the world can do much more than just service your aircraft. Every helicopter operation that you find around the world offers a number of unique experiences. I had one just this last Christmas with one of our customers in Iceland, where they were able to take me and my family for a ride around the volcanoes and the lava fields, and you get all of these different wonderful things around the world, and our service partners will be able to give everybody in our community access to that kind of thing. So we're really just shaping what that vision can practically look like, and then that'll be rolled out across the world to the network.
Very nice. I'm excited to see that in action. It's gonna be very fun. Tim's asking, when you were holding the display in your update, it seems like the display had a lot of smudges on it. Are you looking into further coatings, or is this final?
It has got an anti-smudge coating on it. I think it's just been left lying around the workshop, which is full of oil and grease, to be quite honest. So we probably should have cleaned that. When you look at it, it looks fine. So I think it's just the high intensity lights that we've got in here, and the fact that it's been left in an oily machine shop for a while. So and
there's also a big difference between. Yeah, there's also a big difference between a screen that is black, so it's not lit up, and then a screen that's actually alive. You know, you see that with an iPad or with a computer or whatever happens to be. You open up your computer, if the screen is off, it's gonna look very smudged. The moment it lights up, then basically all of that disappears.
Yeah, and if I was to hold my iPhone next to that screen, the iPhone's got a very shiny face. That screen's got a very sort of satin coating on it, and that makes a big difference. It does mute all of the smudges and reflections very well. So we probably haven't shown it in the best light there, but it does work very nicely.
Brian Kane is asking, where is PC1, please? Now, keep in mind, Jason, that you are a Brit, so we have 90% of our clients are from outside Britain. So please give us a little bit of a context where is located, because sometimes we just say the name of the location and people have no idea, because again, we have 90% of our client base from outside UK. So just give us an overview. So where is this located? What is the environment?
If you look at the map, and if you look at the UK, PC1 is right in the middle. So if you look at Google Maps and look at the British road network, there's a big motorway called the M6, and we're literally right off junction 14 on the M6. So it's right in the middle of the UK. You can fly into Battersea Heliport in about 50 minutes. You can be up in the Scottish borders in about the same time as well. And you can hit the coast in either direction in less than an hour. So we're right in the middle of the UK. It's very, 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 very easy to get to by land and by air.
Good. And I might have missed it. You said it was Stafford.
It's Stafford, yeah.
I'm guessing you said that.
Stafford. Sorry, go ahead.
Now, what's the closest airport also? How do we fly in? It's like what do you
Birmingham.
recommend? Manchester, Birmingham?
Yeah, Birmingham and Manchester would be the easiest to get to. They're both on the M6.
Okay, awesome. Very exciting. Somebody else was asking a question about the simulator. Just wanted to touch on that again, because we didn't really give any really dates or anything. So the plan is by the end of this year to have the simulator up and running fully. So Stanley was asking another question. Are there any plans to have climate control in the baggage area? It would be quite nice to have a separate climate control in this area. And also, I'm going to add a tag onto that as well. Somebody was asking, since the video that we put out of kind of joking about, hey, the baggage compartment is actually big enough that you could sleep in here. We've had a few questions saying, could you actually sleep in there? Are there door handles on the inside that you could open it up so you can't get locked in? Maybe just quickly touch on that as well.
That's a design requirement that I didn't foresee. You know, it was bad enough when people said they wanted
Exactly.
skids, but now they want to sleep in the baggage bay. So, what was the question? Air conditioning? No, the current.
Keep in mind that Tesla Y has
Yes.
Tesla Y has an accessory that you can buy a mattress, so you can have a bed on the Tesla. So maybe you can consider an option to have that mattress on the baggage compartment. Go ahead. Yeah.
Okay.
Well,
Well,
then you need to be able to breathe in there as well, which can be tricky. So you got to be careful with that. So I'll let you talk. Sorry, Jason.
It's not air conditioned because it's currently designed as a baggage bay. There aren't any door handles on the outside, and there are no vents. So it's not air conditioned. You could get in, but you wouldn't get out, and you probably would suffocate.
So just
No
as a
chance to
disclaimer,
camp on the-
do
on
not
the
try
hill.
and sleep in there with the doors closed.
Yeah,
very
okay.
good.
I mean, joking aside, it is big enough. It's maybe something we could look at in the future. Right now, all I really care about is getting my engine to work and getting my helicopter into the air. Once we've done that, I'll look at any options you want me to if there's a big enough market for them. But right now, let's make the thing fly.
There could be.
Fly. Yeah,
That's right.
yeah.
Right now it's the MVP. After MVP, there's a lot of creativity that could be added. For sure, this one is an interesting
sure.
one later.
I think in the discussions that
going
we
to
had
the
on the
remote
joking that we were
sites, you
doing,
know?
I think having sort of a pop-out tent on the side, something that is attached to the baggage bay door when the door is open. There's a tent connected to that, so you could be partially inside the baggage bay and partially out. Something like that, I think, could be quite interesting. Maybe as a future option on that as well.
Come and talk to me again once
Okay.
it's flown.
Yeah, exactly.
James is asking next question. Does the 2 weeks of building the HS50 include the flight training, the emergency procedures, etc., in another HS50, or is it that a separate training? So how do you going to be doing basically, from what I understand from the question, is emergency flight training and the knowledge of the aircraft, is it on yours or another aircraft? Is it a separate training? How do you envision this training? Do you have some ground school that you do? Do you have some just flight? How is this embedded on the build school? So
The build school is a process that will take 2 weeks to build your aircraft to the point that we can sign it off for flight. So the ground school will the flight training will happen on our fleet aircraft, certainly to start with. So I'd consider those things as totally separate at the moment. We've got a big enough task on our hand coordinating the build of all of those aircraft within the windows that we've got. So we'll probably schedule the flight training earlier, so you can come do your type rating, so you're ready to fly your aircraft when it's built. We'll probably do it like that. And of course, the maintenance training is for a different person anyway. For most people, that will be your mechanic that comes on that, not you personally. So consider all of those things as separate.
Very good. Next question is asking, how many part numbers are you up to now?
Oh, I don't know off the top of my head. We're a lot, because there's different configurations of parts as well, and lots of stuff has been superseded, so there's a lot of parts.
Okay.
Speaking of air conditioning, will the air conditioner be developed in-house or be brought off the shelf?
it's a hot topic at the moment. We are trying to buy one off the shelf for those modules because there are some really good units out there that we can use, certainly for the X model. So we're on with that at the moment.
Excellent. And just adding to that, while speaking about the AC, will it be sufficient in tropical environments?
Yeah. So we've got customers in very, very hot parts of the world: Australia, New Zealand, Florida, and so yeah, we've got a very powerful air conditioning system.
Very good.
Will our helicopter have a similar startup and shutdown process and time as the 505?
That's the target. Yes, we need to verify the warm up and the thermal stress profiles on the test bench with the gas generator and the full engine. But fundamentally, yes, we're targeting extremely short startup and shutdown.
How long would that
And
be?
Tim is asking.
You talk about short. How long would that be, Jason?
It's a 30-second cool down on the 505 and the Safran engines. So it's a lot quicker than the 2-minute shutdown on the older Rolls-Royce engines.
Okay. And Tim is asking, service-wise, how much service is required? How many hours between when a technician needs to service the aircraft?
It's on a 100-hour cycle, the same as the 66. So for most private owners, it's going to visit the shop once a year.
Good.
Still on service, can you estimate the service cost for the first 2,000 hours and maybe a percentage of the whole price of the HS50? That's a lot of detail for
probably not off the top of my head. No. So I mean, we're targeting.
It's a general ballpark of idea of 2,000 hours. What's happening in 2,000 hours?
Not a lot in 2,000 hours. In 2,000 hours, you've essentially got 20 100-hour services. Some of the multiples of 100-hour services will pick up some other inspections for the engine, transmission, and some of the other systems, but none of them are major. So the first major maintenance interval you've got is the 5,000-hour mark, where the engine has to be overhauled, the transmission needs to be overhauled, and all of the key mechanical assemblies need to be overhauled and the structure inspected. But that doesn't happen until 5,000 hours. So for most private owners owning a new aircraft, that's never going to happen.
Very good. And we're just getting down to the last couple of questions here, so we're going to be wrapping up very shortly here. If you guys have any burning questions that you still want to ask Jason, make sure you post those now so we can ask them to him. This next one is just a fun question for you, Jason. Why do you not like the skid version, and why do you prefer the wheels?
Because I'm a massive Airwolf fan, right? And so helicopters have wheels as far as I'm concerned. I do like the skid version. I think it looks lovely. It's just, I personally prefer the wheels. I love the idea of being able to move the thing around on the ground really conveniently. And the wheels do make a huge difference to the aerodynamic cleanliness of the aircraft. It is notably faster. So for a machine that you want to go places, the wheels are amazing. So it's just personal choice. I think we've done a great job of the skids. I think Henry's done a great job of the skids, and it does look awesome on skids. But mine will have wheels.
Very good.
Okay, then Justin and Becca, can you talk a little bit about how you're going to make the tail rotor pedals nonlinear and its benefits?
Yeah, so the primary benefit is just to make it feel as much like an open tail rotor as possible. And there's two contributions to the nonlinearity. The main one being that in a ducted fan, only a proportion of the tail rotor thrust comes from the fan itself. About 50% of the thrust will generally come from the inflow that's generated over the lips of the tail rotor duct. But of course that is proportional to the inflow velocity squared into the duct. So that's where the nonlinearity comes from. That's why you need much more pedal travel to get the high levels of thrust than you would in an open tail rotor. And so we can adjust the control rigging to compensate from that. So while you put a linear amount of pedal in, so 50% pedal for 50% thrust, that will change the blade pitch by more than that to compensate for that. There are other non-linear factors that we can't really do anything about without going into wildly complicated things that we're not going to do. So the thrust of a ducted fan will drop off much quicker with rotor RPM than an open tail rotor will. We can't really do anything about that. But the rigging on the control pedals, how we run those control runs, and the geometry of the bell cranks allows us to easily compensate for that non-linearity.
Very good. Maybe we can pick up that second possibility in the future if there's electric motors in the back tail rotor gearbox or something. That would be kind of nice. Next question is from Kevin and says, what will you or won't you be looking to build in the 2 weeks that you're invited to be there for?
So you'll be heavily involved in the, so first of all, let's talk about things you won't have to build. You're not expected to build engines, you're not expected to build transmissions, you're not expected to build rotor hubs, you're not expected to build avionics. And so it's the core fabric of the aircraft. So you'll be heavily involved in the production of your fuselage, you'll be heavily involved in the assembly of the whole aircraft, and you'll be heavily involved in a bunch of areas that, although you're not required to be involved in them, will benefit you greatly as a private owner operator. So I want you to see what's inside your gearbox. I want you to see what's inside your engine. I want you to see how thin some of the components are and why the limits are the limits. So see that process not as contract labor, see that process as a 2-week learning journey, where we're going to teach you as much as we possibly can about how your aircraft really works, so you can operate it safely and respect the limits that are in the pilot operating handbook, because there is physical reasons for those limits within the engineering. The more you see and understand about that, the safer you'll be as an owner operator.
Okay, what about, do you still have plans about the Halfpenny Green site?
Yeah,
anything
absolutely.
planned there?
Yeah, absolutely. So we have a pre-application going through shortly to just understand the full extent of what we might be able to do there in the future. In the short term, we're intending to put a flight operations center there to handle the test flying of the production aircraft. And that's just been timed to be just in time for when we need it. We don't need to be investing big chunks of money into infrastructure like that until we need it. The beauty of the permitted development rights that airport sites benefit from is the fact that with 28 days notice, as long as we're within the scope of permitted development, we can start building. And building a simple flight ops shed, essentially, industrial building, is a relatively quick thing to put up at the scale that we would need there. So we're absolutely pushing ahead with that.
Very good. Another fun question for you, Jason. Lots of fun ones today. Will you be able to do a 1G barrel roll?
A 1G barrel roll. HX50 will not be approved for aerobatics.
Maybe it will be able to, but not approved for, right? So that's the barrier. We don't have, not approved for that.
No, I don't think we need that
out.
kind of trouble, do you? No, it's a conventional helicopter with a conventional operating range, so it's got the full capability in terms of the loads that it can pull for the structural requirements of the design codes. It's got a very, very capable rotor head, but that is to give you margin in demanding environmental conditions. It's not there to be exploited.
Mm-hmm. Good point. Okay, what happens if the wheels don't go down?
That's a good question. So there's multiple levels of redundancy to protect you in that circumstance. So there are multiple ways that the undercarriage locks can be released. We have a secondary blowdown system to allow the undercarriage to blow down if the hydraulic system fails or an actuator fails. And then if that doesn't work, the aircraft is perfectly capable of being landed on its belly.
Okay, that's good. Will the rotor RPM be consistent between flight and hover?
Yes, it's governed to within around a 1% range, and we just operate at 100% all the time. At the moment, we haven't done anything with slower RPM to reduce the noise signature. We don't need that.
Okay.
Next one from Dale. Have you considered an electrically driven tail rotor?
I've considered it along with many other things, but electrically driven tail rotors are still the subject of Airbus patents. So for a little while longer, that's their territory, I'm afraid.
Okay. And can you delete the duct part of a tail rotor or move the duct walls away from the blades to eliminate the issues with the ducted fan?
No. The duct walls are really important to the performance. So the purpose of those duct walls is their proximity to the rotating blade tips inhibits the influence of the tip vortices at the tips of the blades, and then the expanding duct behind the rotor reduces the downwash velocity essentially of the tail rotor and reduces the power requirements. So that whole package of ducted fan, all of the geometry in there is very, very important and very carefully optimized. So there's no simple way to solve that problem beyond what we've discussed and just tweaking the rigging a little bit.
Super. We had a great session today, and this one is going to be the last one. Last question now, and we already have more than an hour and 20 minutes of Q&A. So it's great to have you all. This is going to be the last one for this time. Kevin is asking, are you going to be crash testing the hull like we have seen on many other helicopter manufacturers?
Absolutely, it's a certification requirement. You have to crash test the hull, you have to show that it doesn't spill any fuel, and we have to show that the seats are crash worthy, and there's a bunch of head strike requirements as well. So there's a whole plethora of crash tests that never used to exist that do in the latest certification standards. So this will be the most robustly tested light helicopter that exists by the time we get it through the approvals process. The very latest certification standards from around the world, all of them fully met.
Wonderful.
Fantastic. Great.
Thank you, Jason.
Great to finish. Yes, great time to finish the session. And thank you very much, everyone, for attending today. It was great to have people connecting from all over the world again. It was a great AMA. And we're going to be announcing next one coming up very soon as well. We're going to be continue to doing AMAs. This has been the case since the beginning of the program. And it's a way for you to ask questions directly to Jason regularly. You're always going to be welcome to also join our presentations. We're doing daily presentations, Mishi and I, to educate and make available the opportunity to pre-order the aircraft. We do that daily. You can enroll in our website, and you can choose the day and time. We're pleased to meet you personally on these presentations and to share the opportunity that is currently available. And thank you again for everybody attending today. Have a great day, afternoon, evening, whatever you are.
Thank you very much for your attention, guys, and thanks for the questions. Speak to you soon.